For example, lighting white LEDs can be used in systems assisting people to navigate in closed spaces while searching necessary rooms or objects. 178. Assistive listening devices in many theaters and similar spaces use arrays of infrared LEDs to send sound to listeners' receivers. Light-emitting diodes, as well as semiconductor lasers, are used to send data over many types of fiber optic cable, from digital audio over TOSLINK cables to the very high bandwidth fiber links that form the internet backbone. For some time, computers were commonly equipped with IDA interfaces, which allowed them to send and receive data to nearby machines via infrared. Because LEDs can cycle on and off millions of times per second, very high data bandwidth can be achieved. 179. For that reason, visible light communication, VLC, has been proposed as an alternative to the increasingly competitive radio bandwidth. 180. By operating in the visible part of the electromagnetic spectrum, data can be transmitted without occupying the frequencies of radio communications. The main characteristic of VLC lies on the incapacity of light to surpass physical opaque barriers. This characteristic can be considered a weak point of VLC, due to the susceptibility of interference from physical objects, but is also one of its many strengths. Unlike radio waves, light waves are confined in thin enclosed spaces they are transmitted, which enforces a physical safety barrier that requires a receptor of that signal to have physical access to the place where the transmission is occurring. 180. A promising application of VLC lies on the Indoor Positioning System, IPS, and analogous to the GPS built to operate in enclosed spaces where the satellite transmissions that allow the GPS operation are hard to reach. For instance, commercial buildings, shopping malls, parking garages, as well as subways and tunnel systems are all possible applications for VLC-based indoor positioning systems. Additionally, once the VLC lamps are able to perform lighting at the same time as data transmission, it can simply occupy the installation of traditional single-function lamps. Other applications for VLC involve communication between appliances of a smart home or office. With increasing IoT-capable devices, connectivity through traditional radio waves might be subjected to interference. 181. Light bulbs with VLC capabilities can transmit data and commands for such devices. Machine vision systems. Machine vision systems often require bright and homogeneous illumination, so features of interest are easier to process. LEDs are often used. Barcode scanners are the most common example of machine vision applications, and many of those scanners use red LEDs instead of lasers. Optical computer mice use LEDs as a light source for their miniature camera within the mouse. LEDs are useful for machine vision because they provide a compact, reliable source of light. LED lamps can be turned on and off to suit the needs of the vision system, and the shape of the beam produced can be tailored to match the system's requirements. Biological detection. The discovery of radiative recombination in aluminum gallium nitride, AlGaN, alloys by U.S. Army Research Laboratory, ARL, led to the conceptualization of UV light-emitting diodes, LEDs, to be incorporated in light-induced fluorescence sensors used for biological agent detection. 182, 183, 184. In 2004, the Edgewood Chemical Biological Center, ECBC, initiated the effort to create a biological detector named TAC Bio. The program capitalized on semiconductor UV optical sources, SUVOs, developed with Defense Advanced Research Projects Agency, DARPA. 184. UV-induced fluorescence is one of the most robust techniques used for rapid real-time detection of biological aerosols. 184. The first UV sensors were lasers lacking in field use practicality. In order to address this, DARPA incorporated SUVO's technology to create a low-cost, small, lightweight, low-power device. The TAC biodetector's response time was 1 minute from when it sensed a biological agent. It was also demonstrated that the detector could be operated unattended indoors and outdoors for weeks at a time. 184. Aerosolized biological particles fluoresce and scatter light under a UV light beam. Observed fluorescence is dependent on the applied wavelength and the biochemical fluorophorese within the biological agent. UV-induced fluorescence offers a rapid, accurate, efficient and logistically practical way for biological agent detection. This is because the use of UV fluorescence is reagentless, or a process that does not require an added chemical to produce a reaction, with no consumables, or produces no chemical byproducts. 184. Additionally, TAC Bio can reliably discriminate between threat and non-threat aerosols. It was claimed to be sensitive enough to detect low concentrations, but not so sensitive that it would cause false positives. The particle counting algorithm used in the device converted raw data into information by counting the photon pulses per unit of time from the fluorescence and scattering detectors, and comparing the value to a set threshold. 185. The original TAC Bio was introduced in 2010, while the second generation TAC Bio Gen 2 was designed in 2015 to be more cost-efficient, as plastic parts were used. Its small, lightweight design allows it to be mounted to vehicles, robots, and unmanned aerial vehicles. The second generation device could also be utilized as an environmental detector to monitor air quality in hospitals, airplanes, or even in households to detect fungus and mold. 186, 187. Other applications. The light from LEDs can be modulated very quickly, so they are used extensively in optical fiber and free space optics communications. This includes remote controls, such as for television sets, where infrared LEDs are often used. Optoisolators use an LED combined with a photodiode or phototransistor to provide a signal path with electrical isolation between two circuits. This is especially useful in medical equipment where the signals from a low-voltage sensor circuit, usually battery-powered, in contact with a living LED costume for stage performers. LED wallpaper by Maystyle organism must be electrically isolated from any possible electrical failure in a recording or monitoring device operating at potentially dangerous voltages. An optoisolator also lets information be transferred between circuits that do not share a common ground potential. Many sensor systems rely on light as the signal source. LEDs are often ideal as a light source due to the requirements of the sensors. The Nintendo Wii sensor bar uses infrared LEDs. Pulse oximeter system for measuring oxygen saturation. Some flatbed scanners use arrays of RGB LEDs rather than the typical cold cathode fluorescent lamp as the light source. Having independent control of 3 illuminated colors allows the scanner to calibrate itself for more accurate color balance, and there is no need for warm-up. Further, its sensors only need be monochromatic, since at any one time the page being scanned is only lit by one color of light. Since LEDs can also be used as photodiodes, they can be used for both photo emission and detection. This could be used, for example, in a touch screen that registers reflected light from a finger or stylus. 188. Many materials and biological systems are sensitive to, or dependent on, light. Grow lights use LEDs to increase photosynthesis in plants. 189. And bacteria and viruses can be removed from water and other substances using UV LEDs for sterilization. 92. LEDs of certain wavelengths have also been used for light therapy treatment of neonatal jaundice and acne. 190. UV LEDs, with spectra range of 220 nm to 395 nm, have other applications, such as water/air purification, surface disinfection, glue curing, free space non-line of sight communication, high performance liquid chromatography, UV curing, dye printing, phototherapy, 295 nm vitamin D, 308 nm excimer lamp or laser replacement, medical /analytical instrumentation, and DNA absorption. 183, 191. LEDs have also been used as a medium quality voltage reference in electronic circuits. The forward voltage drop, about 1.7 V for a red LED or 1.2 V for an infrared, can be used instead of a Zener diode in low voltage regulators. Red LEDs have the flattest I/V curve above the knee. Nitride-based LEDs have a fairly steep I/V curve and are useless for this purpose. Although LED forward voltage is far more current dependent than a Zener diode, Zener diodes with breakdown voltages below 3 V are not widely available. The progressive miniaturization of low voltage lighting technology, such as LEDs and OLEDs, suitable to incorporate into low thickness materials, has fostered experimentation in combining light sources and wall covering surfaces for interior walls in the form of LED wallpaper. A large LED display behind a disc jockey. A large LED display behind a disc jockey. 7-segment display that can display 4 digits and points. 7-segment display that can display 4 digits and points. LED panel light source used in an early experiment on potato growth during shuttle mission STS-73 to investigate the potential for growing food on future long-duration missions. LED panel light source used in an early experiment on potato growth during shuttle mission STS-73 to investigate the potential for growing food on future long-duration missions. Research and development. Key challenges. LEDs require optimized efficiency to hinge on ongoing improvements such as phosphor materials and quantum dots. 192. The process of down conversion, the method by which materials convert more energetic photons to different, less energetic colors, also needs improvement. For example, the red phosphors that are used today are thermally sensitive and need to be improved in that aspect so that they do not color shift and experience efficiency drop-off with temperature. Red phosphors could also benefit from a narrower spectral width to emit more lumens and becoming more efficient at converting photons. 193. In addition, work remains to be done in the realms of current efficiency droop, color shift, system reliability, light distribution, dimming, thermal management, and power supply performance. 192. Potential technology. A new family of LEDs are based on the semiconductors called perovskites. In 2018, less than 4 years after their discovery, the ability of perovskite LEDs, PLEDs, to produce light from electrons already rivaled those of the best performing OLEDs. 194. They have a potential for cost effectiveness as they can be processed from solution, a low cost and low tech method, which might allow perovskite-based devices that of large areas to be made with extremely low cost. Their efficiency is superior by eliminating non-radiative losses, in other words, elimination of recombination pathways that do not produce photons, or by solving out coupling problem, prevalent for thin film LEDs, or balancing charge carrier injection to increase FEQE, external quantum efficiency. The most up-to-date PLED devices have broken the performance barrier by shooting the EQE above 20%. 195. In 2018, Cao et al. And Lin et al. Independently published 2 papers on developing perovskite LEDs with EQE greater than 20%, which made these 2 papers a milestone in PLED development. Their device a similar planar structure, i.e. the active layer, perovskite, is sandwiched between 2 electrodes. To achieve a high EQE, they not only reduced non-radiative recombination, but also utilized their own, subtly different methods to improve the EQE. 195, in the work of Cao et al.